Hi, Viper Chemistry students. We're going to work a problem involving molarity and how it changes or dilutes the solution when the volume changes. So let's take a look at that. We have a given value of a solution of ammonium chloride, and we know that there's 50 milliliters. That's the first volume. And we know that the molarity is 3.79 molar. Okay, so we have that first solution going in, but we're going to bring the solution up to 2 liters. So we're changing that volume value. So let's see how we work a problem like that. So what we do is we write our knowns. The first molar value is 3.79. And then the first volume is 50 milliliters. What we're going to try to solve for then is how does that change the molarity? So that's what we're looking for. The molarity will change. The concentration of the solution will change if we change the volume. So by changing the volume to 2.0 liters, now what we have done is we have diluted the solution. Okay. So but the problem here is that we have milliliters here, we have liters here, so we got to make that change. So we can convert that by knowing that there's 1,000 milliliters for every 1 liter, and so that gives us 2,000 milliliters. So that's the one we want to work with because we want to make sure that our units coincide for volume. Now the original equation for this that we're working with to solve these types of problems is that you start with the product of the molarity times the volume of the first case equals the product of the molarity times the volume of the second solution. Okay, so how do we solve for that? We've got to transpose our equation then to solve for M2. And so we have M1 V1 over V2, which if we plug everything in, we have 3.79 molarity times the first volume of 50 milliliters divided by the volume 2 of 2,000 milliliters. And then that results in, when we calculate that value, and we have 0.09 molarity. Okay, so as you can see, the molarity has decreased from 3.79, but we added an awful lot of solution here from 50 milliliters up to 2,000, so that makes sense that would reduce that molarity to that value. Okay, thank you for watching and good luck on these types of problems. Talk to you later.